Okay, so in today's lecture, we will do balancing of redox equations using ion electron method, and we will learn the technique for solving these equations both in acidic and basic medium. So we are doing initially acidic medium. We'll take a handful of examples. So over here, suppose you are given MnO4 minus, and it is being said it is going to Mn2 plus. So first of all, we have to calculate for the oxidation state for Mn. So if we do that, we know Mn is X. Okay, there are 4 oxygens, so minus 2 into 4, which is 8, and that is equal to minus 1. So the value of X will come out to be as plus 7. Okay, so this is plus 7, and this out here is plus 2. So there is a 5 electron reduction for Mn. Now we have to balance the oxygen. For that, for the reaction in acidic medium, you add water on the right hand side, or water to the side opposite where the oxygen is. So if the oxygen is in here, we add water here. Now how many oxygen are there? We will say 4. So we multiply the water molecule by 4, and to balance the hydrogen, now we will add proton on the left hand side. So it will be all total 8 protons. Okay, now if you check the total charge on the right and left hand side, which should be balanced. So over here we can see we have, if we add these two, it is 6 unit of negative charge. Okay, and this is 8 unit of positive charge, which means charge on the left hand side is plus 2. Water is neutral, we know, and what is the charge on Mn2 plus? It is plus 2. So charge on both the sides is balanced, and so this particular equation is also balanced. Okay, now suppose we have been given to balance the redox titration of oxalate with MnO4 minus, and suppose they are saying that oxalate is going to carbon dioxide and Mn is going to Mn2 plus. So now here we know this is plus 7, this is plus 2. So obviously out here, over here, the reduction is happening. Okay, so we call this as the reduction half cell, and over here we can see carbon dioxide should be plus 4 here, and if we calculate for this one, we will say carbon out here, if we calculate, we will say it is 2x. We are calling x is the oxidation state for carbon, so there are 2 now, so we multiply by 2. Okay, so 2x minus, we have 4 oxygen, so we say 8, and that is equal to minus 2. So if we solve for x, we will say x will be having the value plus 3. So over here it is plus 3, and then it is going to plus 4. So each of the carbon is getting oxidized by 1 electron. Okay, and so we will call this as the oxidation half cycle. And hence, when a reaction, when both reduction and oxidation takes place, it is called a redox reaction. So the reaction below is a redox reaction. Now, so what we do is we isolate the reduction half cycle and we balance it. So we know this already, we have balanced it in the Same page, so it is 5 electron, we have 4 water, and we say it is 8 protons. And for the other one, which is C2O4 2 minus, going to carbon dioxide. Okay, so there are 2 carbon dioxide. There are only carbon and oxygen on the left hand side and carbon and oxygen on the right hand side, so no need to add any other atom, but only need to balance the electron. So over here we are saying it is each of the carbon is releasing 1 electron, so 2 electrons are released in total. And so now we can see both in the left hand side and in the right hand side the charge is also balanced, which is -2. So now before we add this equation, say 1 with equation 2, think these equations as simultaneous equations, and you have to make the electrons equal over here. So for that, this total equation we will multiply with 2, and this total equation we will multiply with 5. That will make our number of electrons equal, and then we add them so that they can be cancelled. So that way if we say, we will say this is 16 proton, 2 MnO4 minus plus 5 C2O4 2 minus, that goes to 2 Mn2 plus 8H2O plus 10 CO2. And that is how we have to balance a equation in the using ion electron method. Now, suppose we were asked to calculate in the above equation what is the equivalent weight, then we will say equivalent weight will be molecular weight of, if they are giving iron, then use the iron, or if they are giving the uh, chemical substance, that is KMnO4, then use KMnO4. So if they say for KMnO4, then simply you divide it by the number of electrons involved over here, number of electrons involved. That will give you the equivalent weight of the KMnO4. Okay, so next we will be taking an example in which we will try to balance a redox equation, and that would be in alkaline medium. Okay, so let's take an example of that kind. Okay, so suppose I have given you one equation over here. So this is balancing redox equation in alkaline medium. How to do that? They have given you Zn, okay, NO3 minus, ZnO2 2 minus, NH3. Okay, and they're saying this is occurring in alkaline medium. Now what you do, you see Zn is in zero oxidation state, and if we calculate the oxidation state over here, which is X, so we'll find that Zn should be, so here it is X minus 4 minus 2 So X becomes plus 2. So we will say this is plus 2. So obviously this is undergoing oxidation. So this is my oxidation half cycle. What about from here to here? Hydrogen we know is always positive. So if this is X, then we will say plus 3 and 0. So obviously we will say for ammonia it is minus 3. For ammonia, the oxidation state of nitrogen is minus 3. And for this one, if we calculate for this one, we will say it is, we are doing it over here separately. X for oxygen it is minus 2. So 3 into minus 2 is 6 equal to minus 1. So therefore, it will be plus 5. So out here this is plus 5. So from plus 5 to minus 3 is basically reduction by 8 electrons. So this is my reduction half cycle. Now having identified both these things, what we need to do over here is we write the half cycle for NO3 minus. So we write NO3 minus and we have NH3. Okay, that is what we do. So now again, this is 8 electron reduction as I have said. So what you do first of all, to balance the oxygen, we have to add water. So over here we add water, which is going to be multiplied by 3. Okay, for that now we will get 6 protons, which we add over here. But since we are saying this is alkaline medium, occurring alkaline medium, so we have to neutralize this 6H. How do we do that? By adding OH. So what we do is we add 6 OH over here and similarly 6 OH over here on both the sides. Now this is OH and H gives you water. So now what we do, we rewrite this whole equation. We write 6H2O, HNO3 minus, 8 electron, NH3, 3H2O, 6OH minus. Now if you see 6 water here, 3 water here, so we will remove this water molecule and we will write simply as 3H2O over here. Now if you check, okay, if you check over here, what we will say,